In this tutorial, we are going to make a classic hard surface model in Blender. So to make that model, we need to add a cylinder and vertex should be 10. We can go with the 10 words because we will create the simple and crazy hard surface model. So just delete the bottom word so you will get a 2D planar shape. Then snap it to the 3D cursor and then rotate it into, I need to calculate the right degree here. So just rotate it into the 18 degree and now you need to select the words like this and then connect vertex path. Just select the words, right click and then connect vertex path. Same thing for all words. Then you can see we have created chord-based topology. Then select that center edge and add a bevel on that edge. One segment is fine. Now you need to select these faces and then move these faces along the y-axis like this. Okay, then you can scale them. Okay, so then scale them along the x-axis and just try to get the good shape right here. And for that, n number of times you can adjust the shape of your model. Just try to get the good shape. Okay, then select the outer edge and then extrude it, and then you can move it along the z-axis and then scale it like this. You can adjust the scale. Okay, now I think I need to scale it along the x-axis and then one more time extrude it and then scale it. Then one more time scale it along the x-axis to get the even space. Then you can add the solidify modifier and give the proper thickness for your solidify modifier. Okay, that's look pretty well. Now you can select these faces, the inner faces, and then press I to insert these faces. And then you can extrude them. Okay, now you need to adjust the height of these faces from the surface. Okay, now you can scale them, scale it down. Okay, then scale it down along the x-axis, and that's look pretty well, decent. You can see easily we have formed this shape. Then select these faces and then press I to insert. It's not necessary here. We will insert at the end of this model, so we will get the sharper edge. Then add a cube, and this cube will work as a cutter object for our model, and so we can create a simple and easy booleans on our model to get that look, sci-fi look and more hard surface look. So then just rotate this cube like this, and you can use the local axis rotation and just try to fix your cutter object at the right position. And then just move these words to get the good shape, and then you can add a mirror modifier. Before that, set origin to the 3D cursor of your object. Now it's look pretty well. Now you can apply that mirror modifier, and just you need to use the bool tool and then difference operation, boolean operation, difference boolean operation. Otherwise you can use that boolean modifier also. Then shift D to duplicate just for the backup. Now you can apply that boolean modifier and delete the cutter object. Now just you need to add a loop cut supporting edges, which are very important in the production modeling workflow, because we will add a sub-D modifier, and which creates a weird geometry if you won't have the supporting loop cut. So that's why you need to add the supporting loop cuts and supporting edges, which will maintain the shape of the geometry, shape of your object. So just add a loop cuts like this and try to create the chord-based topology. Few triangles are fine, and try to avoid the n-gons. So now you have to use the symmetrize option to get the same kind of design on the another side. But before that, you have to apply the location and rotation. So Control A and then apply the location and rotation on your object. Then you can go for the symmetrize and then you will get the proper result with the symmetrize option. Then you can add the subdivision surface modifier. Okay, then increase the level and you can see our mesh looks pretty well. We need to add few more supporting loop cuts. So just add those supporting loop cuts like this and just try to get the good shape for your mesh, and you can dissolve the unnecessary loop cuts also. Then Shift D to duplicate just for the backup. Now just select these faces and we will press I to insert, because now the insert operation is important. So you will get the proper shape for your mesh. So after insert operation, you can create a little bit of design on your mesh. So just here is a design sense which will help you to get the good shape. So that's why you need to try few more attempts to get the proper shape, proper design for your mesh. So now select these faces and press I to insert. And just make sure that all words should be in the straight, so which will help you while creating such kind of booleans insert operations. So select the faces and press I to insert, and now you can select the faces and then you can extrude inside them like this. You can use the extrude operation and you can create easily a good design on your mesh. Then add one more time supportive edges, supportive loop cuts to tighten your geometry, so you will get a good result from it. Now you can use the symmetrize option, which will give you the same result to the another side. And now our mesh looks pretty well. Make sure your edges should not be too close to each other, which will create a weird geometry, weird topology, and you will get that weird look for your mesh. Somewhere will be the hard edges like this, so that's why you need to maintain the edge flow. And if it's not necessary, then just dissolve your loop cuts edges, so you can maintain the edge flow and good curve reshape for your model. Personally, I like to give the natural number for the supporting loop cuts, so if I miss something, then I can add a loop cuts with the same number, so it will be remain in my memory, so I can easily remember that number. So that's why I like to give the loop cuts their factor amount in a natural number, like a 8 or 9.8, 0.9, something like that, not in the 0.75, 0.863, something like that. So you can press Ctrl while adding the loop cuts. Ctrl R to add loop cuts, then one more time you need to press Ctrl and you can use the edge slide. Now select these faces and then press I to insert these faces, and now you can use the loop tool to make it circle. Sorry for the background noise, there is a little bit of noise. Just here I have created a simple hole with a simple technique. Now our mesh looks pretty well decent. Now select these faces and then I to insert these faces, and here we will create a tube kind of shape which you can see which will protect our mesh, something like that. The design sense is there. So just extrude these faces and then scale it down and you will get something kind of this kind of result. You can adjust the scale along the x-axis and the y-axis, and you have to do this manually. So we will get that organic kind of feel, organic tube kind of effect here. Then just add a loop cuts on its edges, not on the outer edges, means where it's a joint, add the loop cuts at only there. So you will get this kind of tube kind of effect which feels like organic more. Then adjust the scale. So you need to select these faces and we will create different kind of shape here. So just extrude these faces and then move them along the x-axis and then scale it down like this along the x and y axis. Now you can select the top faces and then use the insert operation. Before you should know the edge flow here, so just select these edges and double tap G to slide those edges. Otherwise we will get the weirdness on our mesh. So that's why we need to maintain the edge flow and the right spacing. So that's why you need to drag these edges, then select the faces and then use the insert operation. Okay, now you can extrude inside this like this and give the proper extrusion amount. Then one more time insert it and give the small insert thickness. Then add a loop cuts which will support our geometry, which will maintain the shape of our mesh. And that's look pretty well. Now add loop cuts from the outer side, and you can see by turning on your subdivision surface modifier where you need to add a loop cuts. So add a necessary loop cuts. Like this. Just try to get the proper shape for your mesh. And now our mesh looks pretty well decent. This flex will work as a holder, so we can fix the nuts and bolts, something like that, and we can fix this part on any surface. So this is just a design sense. Then you can take the symmetry, and maybe you will face a little bit of difficulty here, so just you need to merge these words at the center, and sometimes these things happen while taking a symmetry. And now our mesh looks pretty well decent. That's look fine. Now we select these faces and we will create a whole kind of shape right there. Before that, just add a loop cut at the center from top and bottom both sides. Then select these edges and then add a bevel on these edges. And now you need to add a loop cut. So add 2 loop cuts and select these faces and then delete these faces. Or you can use the insert operation and then you can delete the center faces. And you can see our mesh looks pretty well decent. So add a supportive and necessary edges loop cuts just to maintain the shape of our mesh. And you can see our mesh is looking pretty well, decent kind of modeling we have done here. Now just select these faces and just with a simple extrude and bevel operations we can create a little bit of design on our mesh which will look more cool. Then extrude it outside, and this will also work as a tube kind of shape, as like an organic modeling. So just add a loop cuts at the bottom. So here is also design sense. If we press something else, so anything on this surface on the top of this model, then it won't get harm the inner core. So that's why these kind of tube shapes are there, which will protect our mesh, means inner part of our main model. So this kind of design sense is there. Then add the cylinder, and here we will create the core shape of this model. So this will be the core part of our model. Now select these edges. Make sure you select equal number of edges from the both side, and then you can use the bridge edge loop option. Now select this bottom face and then insert this face. And shade smooth it and then increase the subdivision level. And now you can see we have easily created this core part of our model. And here you can use the same technique, bridge edge loop technique. So just select the equal number of edges from the both side and then right click and select the bridge edge loop option. If you don't select that equal numbers, then you won't be able to apply that operation. So that's why you need to select the equal number of edges. And now you can see this looks pretty well and the topology is also pretty fine. Now just adjust its scale and fix it at the center of our model. And now you can add nuts and bolts on your mesh to give it more beautiful look, more realistic looks, like a mechanical thing, like a hard surface. So before that, just select these faces and then press I to insert and use the insert operation right there to tighten that geometry. And it's look decent. Then use the bolt factory add-on and add nuts and bolts. Here I will use only the bolts. And you can choose any bolt, whichever you like. These bolts won't give you the right kind of topology which is necessary for the production modeling. Personally, I use my own bolts model which I model with the right topology. Just for this tutorial purpose, I am using this to speed up my process. And you can choose any kind of bolt design, whichever you like. Just make sure it should be look fine with your model. It should be look good. And you can see in this model we have used both hard surface modeling as well as hard surface organic modeling. That tube kind of shape feels that it's the organic hard surface modeling, and remaining all of the mesh is the pure hard surface modeling. And then you can shade smooth it. So here I mess up that the option, so that's why. Just shade smooth it, and then you can turn on the auto smooth option. And then you can set their origin to the 3D cursor, and then you can add a mirror modifier on it, so you will get the mirror object on the other side of this bolts. And then save your file, and you can see our mesh looks pretty well. Decent kind of modeling we have done here.